In the last lecture, we had started capacitors. We had seen the different types of capacitors, the working principle of capacitors, and also introduced the capacitors in parallel and capacitors in series. In today's lecture, we are going to find out the value of capacitors when connected in parallel and equivalent capacitance when connected in series. First, we will see the capacitors connected in parallel. Here we can see capacitors C1, C2, C3 are connected in parallel. Parallel means what? If one terminal, if terminals are connected together, then that connection is called as parallel, and the parallel equivalent capacitance is given by the formula C is equal to C1 plus C2 plus C3 for n capacitance. Likewise, for 3 capacitance, we can write the formula as C parallel is equal to C1 plus C2 plus C3, and from this formula we can calculate the equivalent capacitance value by putting the values in the formula, and here the C1 is given 10 microfarad, C2 value is 20 microfarad and C3 is 30 microfarad. So, by putting these values into this equation, we can get the equivalent capacitance here is 60 microfarad. So, the equivalent parallel capacitance can be calculated. Next, capacitors in series. In resistors, if resistors are in series, then we have to add the resistors, but in capacitance, if they are parallel, then we have to add as it is its values. But if capacitors are in series, then the equation for the capacitance in series, it is its reciprocal. That means, for n capacitance, we can say here 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3, likewise plus 1 by Cn. So, for if 3 capacitors for here shown 3 capacitors are in series, C1, C2, C3 are connected in series, and its value also given is 10 microfarad, 20 microfarad, 30 microfarad. For 2 series capacitance, we can calculate the series equivalent series capacitance as 1 by C series is equal to 1 by C1 plus 1 by C2, and by evaluating this, we get the equivalent series capacitance as C series is equal to C1 C2 divided by C1 plus C2. Likewise, for 3 series capacitance, we can write the equation as 1 by C series is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Likewise, if we put the values into the equation, then first we have to calculate for the 2 capacitors in series, then calculate this or evaluate this value with the third capacitor. So, here calculation is done for 2 capacitors first, and then it can be added with the third capacitors. So, we know that C1 C2 10 microfarad into 20 microfarad divided by 10 plus 20 microfarad. So, its equivalent will be, if we calculate this equivalent, then we get the value for 2 capacitor, it is 6.67 microfarad plus 1 by 30 microfarad. If we again apply this formula to this equation, then we will get the C series, it is equal to 5.45 microfarad. Likewise, we can calculate the value for n capacitors connected in series and n capacitors connected in parallel. Next, we have to see actually we had discussed these ceramic capacitors. The values of ceramic capacitors shown on their body are in the picofarad value, and actually if we use in applications, then we require it in the microfarads. So, to obtain the values in microfarads, we have to do some calculations here. So, that calculations, how to convert this picofarad value into microfarad, we have to discuss here. You can see in this image ceramic capacitors shown. The values are printed on their as 22, 104, 202, 105. Likewise, these values are in the picofarad form. पिकोफॅरेड मध्ये ह्या व्हॅल्यू दिलेल्या असतात आणि आपण ॲप्लिकेशन जर करायचं म्हटलं तर आपल्याला मायक्रोफॅरेड मध्ये व्हॅल्यू गरजेचे आहेत. सो मग त्या मायक्रोफॅरेड मध्ये कशा कन्व्हर्ट करायच्या, तर त्यासाठी आपण या ठिकाणी डिस्कशन करूयात. let us take, we will take one example, convert 104 pf into microfarad. Okay, so here we have to convert this value into its microfarad. The value given is in the picofarad. Pico means 10 raised to minus 12, micro means 10 raised to minus 6. So when we have to convert this value into microfarad or nanofarad, one thing we have to remember, or one some steps we have to follow, as if this is 3-digit number, then take first 2 digit as it is and third one as a tens power. जर आपल्याला अशी व्हॅल्यू दिली असेल तर आपल्याला पहिले 2 डिजिट जे आहेत ते ॲज इट इज घ्यायचे आणि जो तिसरा नंबर आहे तो तिसरा नंबर आपल्याला रेस टू 10 घ्यायचा आहे आणि मग त्याच्यानुसार आपण पुढे कॅल्क्युलेशन करणार आहोत. सो फर्दर वी कॅन राईट हिअर ॲज 104. For 104 we have to write first 2 digit as it is. That's why we will write here 10 as it is, and this 4 as a tens power. So into 10 raised to 4, and this value is given in the picofarad. So here pf. If we replace this p, we want to replace this p, then we need to put 10 raised to minus 12 in the place of p. That's why 10 into 10 raised to 4 into 10 raised to minus 12 f means this value will be in the farad. Okay. Then we have to calculate further. We have to do here is the mathematical operation. As we know that 10 च्या raised to काही नाही आहे, म्हणजे काय असतो तिथं 1 असतो. So 10 raised to 1 into 10 raised to 4. जर बेसची मल्टिप्लिकेशन असेल तर पॉवरचं काय होते, अरिथमेटिक ऑपरेशन ॲडिशन होते, बरोबर. सो हिअर बेस सेम आहे, मग या ठिकाणी काय होईल 4 minus 12. सो वी विल गेट हिअर 10 raised to 1 into 10 raised to minus 8 f. Then again now we have to convert this value into microfarad. For microfarad we need the power of 10 raised to minus 6. So we can write this minus 8, 10 raised to minus 8 in separate form like this, 10 raised to minus 2 into 10 raised to minus 6. So what will happen here, 10 raised to 1 into 10 raised to minus 2, and if we multiply these two, then there will be 10 raised to 1 minus 2, and 10 raised to minus 6 can be replaced by the sign micro for 10 raised to minus 6. That's why we will get here 10 raised to minus 1 microfarad. 10 raised to minus 1 means 1 upon 10. and we can write it as 0.1. Okay. So for 104 pf we get the value of capacitor 0.1 microfarad. If जर तिथे सांगितलं असेल तुम्हाला की 0.1 मायक्रोफॅरेडचा कपॅसिटर तुम्हाला यूज करायचा आहे, तर तुम्हाला कुठला चूज करावा लागेल? सिरॅमिक कपॅसिटर. यू मस्ट चूज द 10 pf कपॅसिटर. ओके. Similarly, we can see another example for getting more about it. So we will discuss for 102 pf. Now in previous example there were 104, now we have to discuss for 102 pf. We can see here similarly we have to do here. Take first two digit as it is 10 into 10 raised to, take third digit as a tens power, then 10 into 10 raised to 2 pf, then again replace this p by 10 raised to minus 12, we get 10 raised to 1 into 10 raised to minus 10 raised to 2 minus 12, means it will get 10 raised to minus 10. Now again further we need to convert this into minus 6, so into microfarad. So we have to separate this minus 10, likewise minus 4 and minus 6. So I separated these two, 10 raised to 1 into 10 raised to minus 4 into 10 raised to minus 6. Now we can replace this 10 raised to minus 6 by microfarad, and this the base are same, so powers will be added 1 minus 4. That's why here we will get 10 raised to minus 3 microfarad. It is equal to 1 by 1000. Means if we do this, then we will get, there are three decimals are there, so the decimal point will be shifted to left by 3 decimal. So it will be 0.001 microfarad. So we get here for 102 pf the value of capacitor in microfarad is 0.001 microfarad. Likewise we will see how to convert this pf into nanofarad also, but before going to see nanofarad value, you do some exercise on this, then we will discuss about nanofarad. Nanofarad means what? It is a 10 raised to minus 9. So for exercise you do or calculate the 101 pf, 103 pf and 105 pf into its microfarad. Okay, so we will stop here. Thank you.